Let's look at simplifying trig expressions. We're going to use these identities again, and we are also going to use some of these new identities down here. And when we say to simplify, we want to reduce the expression so that we're writing it in with the fewest amount of trig functions that we possibly can. So here we're given sine theta cosecant theta over cotangent theta. We want to simplify this. So a good way to start these problems is to rewrite these in terms of sines and cosines. So cosecant I know is 1 over sine, and cotangent I know is cosine over sine. And then we can go ahead and simplify what we can. So sine over sine cancels to be just 1. And then we have cosine theta over sine theta. And then when we have, when we're dividing by fractions, we keep change flip. We keep the top the same, change division to multiplication, and flip the denominator. So that'll become sine over cosine. And 1 times sine over cosine is sine over cosine. And sine over cosine is tangent. And that is as simple as we can make it. You wouldn't want to leave it as sine over cosine because we can write it in terms of 1 trig function rather than 2. So if you can, the fewer trig functions you can write these in, the better. All right, let's look at another one. Alright, so to simplify this, again, a good thing to do would be to rewrite these in terms of sines and cosines. Alright, so tangent is sine over cosine. So I'll rewrite tangent squared as sine squared over cosine squared. Cosecant is 1 over sine, so I'll write that as 1 over sine squared minus 1. Secant squared is 1 over cosine squared. So again, I'm just rewriting these in terms of sines and cosines. You'll notice that sine squared over sine squared can cancel. So we have 1 over cosine squared theta minus 1 is divided by 1 over cosine squared theta. We can keep change flip, so we keep the top the same and flip the bottom, so we're multiplying that by cosine squared over 1, or just cosine squared. From here, if we were to distribute that cosine squared, we get cosine squared over cosine squared is 1, and then minus 1 times cosine squared is cosine squared. And then if we were to look back at our Pythagorean identities, recall that sine squared plus cosine squared is equal to 1. So if you were to subtract that cosine squared over, you get that 1 minus cosine squared is equal to sine squared. So here we can actually rewrite 1 minus cosine squared as simply sine squared theta. Okay, this is where we're going to have to use those negative and cofunction, let's see, is it called cofunction? Yeah, negative angle identities and cofunction identities. So we know that cosine of pi halves minus theta right here is the same as sine theta. So let's rewrite that as sine theta. And we know that cosine of negative theta, if we look up here, is just cosine. So we'll write that as cosine theta. And there's really no way to simplify these down any further. So that would just be our solution. That's our simplification. Alright, on the next one, again, we want to rewrite these in terms of sines and cosines. Oops. So secant is the same thing as 1 over cosine, and then that's being divided by sine. And then here, this actually looks really similar to what we did over here, where we found that sine squared equals 1 minus cosine squared. So this we can rewrite as just sine squared. So look here, we can cancel out this sign with one of these signs. So we are just given sine theta over cosine theta, and that is equal to tangent theta. And that's as simple as we can go.